Hey, geometry, here we go with the last lesson in Unit 9. So it's very similar to what we just got done doing in Lesson 5. There's just a small difference, and you're going to see what that is here in a second. So in the previous lesson, we derived a formula for finding the area of a regular polygon. You will remember it is 1/2 AP. The three shapes we used in that lesson were an equilateral triangle, and it had to be equilateral because it had to be a regular polygon. So let's put triangle there. We also used squares. And the last one was a regular hexagon. Why did we use those three? It was because those three shapes made special right triangles when using the apothem and radius. Number 1 and 3 was a 30, 60, 90 triangle. So the equilateral triangle and the hexagon made 30, 60, 90 triangles, and the square made a 45, 45, 90. So that's all great, but what happens when you don't have a special right triangle? Here we go. So in this picture here, this is a regular pentagon. It's got 5 sides, called a pentagon. What is the measure of XCZ? So XCZ, that's a central angle made by 2 radii. One of those is 360 divided by, there's 5 central angles. That gives me 72. So XCZ is 72 degrees. What is the measure of YCZ? So that's the apothem in the radius. Cut that in half, you get 36 degrees. Okay, so we do not have a special right triangle. That's the key thing I want you to see here. We know the perimeter, or we can figure out the perimeter very easily. Go ahead and try and fill that in. It is 40 centimeters, 8 times 5. How do we find the other piece, the apothem? We have to use trig. If you looked at the learning target, you knew that, but here we go. So if I'm going to find the area of this, okay, we need 1/2 AP. Just to stay consistent, I'm going to do this again. We already know the perimeter is 40. Now we need to find the apothem. So I'm going to draw the triangle that is made by the apothem and the radius. All I know here is that this side here is 4, right? A side length is 8. So YZ, so XZ is 8, YZ is 4. All right. And a lot of people are going to look at that and say, oh, it's a short leg. And so my apothem's 4 radical 3. Well, that's only true if you have a 30, 60, 90 triangle. I don't. I have a 36-degree angle there. I can't find that missing side using a special right triangle. What can I use? I can use trig. So how do I find A? This goes back to Unit 7. I know the opposite side, and I know the adjacent side. So that's tangent. So the tangent of 36 equals 4 over A. Now you remember how we solved that. We multiply by the denominator, which is a variable here. So A tan 36 equals 4 divided by tan 36. And this is where you're going to have a hard time, right here. Okay. Notice the question I have on the notes. It says, what is the exact value of the missing piece, or the apothem? The exact value is 4 over tangent 36. If I type that in my calculator, I will get a decimal. And if I round it at all, it's not the exact value. So 4 divided by tangent 36 gives me 5.50552768.2. Sorry, there's a scratch in my calculator. But I don't want to round it, and I'll show you why here in a second. Okay, let's find the actual answer of this thing. So the apothem here, I want to use 4 over tangent 36. So there's my stuff. I'm going to change to a different color so you can see me doing this. So 1/2 times 4 over the tangent of 36. And then on top is the perimeter of 40. Could do it 40 over 1 if you wanted. but that's a 40. So now I'm just going to multiply the top and the bottom. So 4 times 40 is 1600 or 160, sorry. And on the bottom is 2 tangent 36. 160 and 2 reduces to 80 over the tangent of 36. Notice I have not even gone to my calculator yet. All right. So I'm going to do that real quick. 80 divided by tan 36 is 110.1. So I can't quite see it here on my computer, but what is the area of this polygon to the nearest tenth? It is 110.1 centimeters squared. Now I said I was going to show you if I had rounded the 4 tan 36 too early and said 5.5 here. Let me show you what would happen. Change to a different color yet again. So let me use the 5.5 this time. Times 40. It's going to be really close to 110. But this says it's exactly 110. So we're off by 1/10. Not a huge difference, but enough to be significant. Okay, so we don't want to round until the very end. And the way you do that is what I did there. You want to leave your trig alone until it's time to type it in the calculator. We're going to do a couple more problems like this, so you'll see what I mean as we go. All right, find the area of a regular octagon with a radius of 9 feet. Now, I didn't give you any pictures here. Hopefully, I'm hoping you can get to the point where you don't need pictures. I'm going to still draw a triangle, but I'm not going to draw an octagon. I need the apothem and the perimeter. I can't get either one with the radius is 9 feet. But I am going to draw a triangle. I always want to draw a triangle here. So this is the apothem, right? Because it's perpendicular to the side. This over here is 9, the radius. That's the hypotenuse of this thing. Okay. And I'm going to put this as y. So a side length, right, is going to be 2y. So I'm going to write that down. Side equals 2 times y. Now I want to find my perimeter and my apothem. To do that, I need my angle. So an octagon has 8 sides. So 360 divided by 8 gives me 45. And then the apothem cuts that in half, and I get 22.5 as my angle. So 22.5 degrees is right there. So now to find the apothem, I have the adjacent side and the hypotenuse. That's cosine. So the cosine of 22.5 equals the apothem over 9. Multiply by 9, and that's the apothem. So the apothem is equal to 9 cosine 22.5. Notice I'm not putting anything in the calculator yet. All right, I'm going to switch colors because I know it's kind of getting all mixed together here. Let's find y. Well, that's y is opposite 22.5, and 9 is the hypotenuse, so we're using sine. So sine of 22.5 equals y over 9. So y is equal to 9 sine of 22.5. Now, don't fall for the trap of just typing that in for the perimeter. That's just y. Remember, a side is 2 times that. So a side in this case is going to be 2 times 9 sine 22.5, which is just 18 sine 22.5. But that, again, is not the perimeter. That's a side. How many sides does an octagon have? It has 8. So I'm going to do 18 times 8, and I get 144 sine of 22.5. I know this looks disgusting, but the only thing I've typed in the calculator right now is 9 times 18, or 9 times 2, and then 2 times 8, or 8 times 18. That's about all I've typed in the calculator right now. Okay. Now that I have my apothem and my perimeter, I'm going to switch colors here, and I'm going to go over here, and I'm going to write this down as is. Don't round anything yet. All right. I'm still not rounding anything. I'm going to take 9 times 144 and divide that by 2. So 9 times 144 divide by 2, I get 648. But then I've still got cosine 22.5, sine 22.5. So now it's just going to be 648 times cosine 22.5 times sine 22.5. One time I'm typing this in the calculator and I get 229.10 or just 229.1 feet squared. Okay. I know that's probably overwhelming. These numbers look disgusting. We're going to take this kind of slow, and I'm going to keep going in class with this, but that's it for the regular polygons. There's a little bit more on the back that I'm going to explain. The next formula is going to seem unconnected to what we've been doing. These are not regular polygons at all, but we are doing it now because it involves area and trig. Just like the front page had trig involved, this has trig as well. So I'm going to derive the formula, show you where it comes from. H and A, we don't know. C, A, and B, no, we don't know them right now, but in the practice problems coming up, we will know the two sides and the angle between them. That's what that's showing. Okay, so the area of a triangle, just in general, is 1/2 base times height, right? And I'm going to show you how this new formula comes straight from that. Well, the base is B, right? The height, I don't know, but I'm going to use big A, C, and B as much as I can to figure that out. Well, if I look at that triangle there on the left with H here, C here, and this is angle A, H is opposite, C is the hypotenuse. So I could say that the sine of A equals H over C. If I multiply both sides by C, I get C sine A equals H. So H equals C sine A. So now what I'm going to do is I'm going to put those into my formula. A equals 1/2. B is B. And then H is, instead of H, I'm going to put C sine A. And there you go. That's the formula. The area of a triangle, a different way, is A equals 1/2 BC sine A. Okay. So it's exactly the same formula. It's just H looks a little different, a lot different. So we'll do a couple practice problems and then we'll be done. All right, so first one's very straightforward. I gave you the two sides and the angle between them. So the area of this is 1/2 B. It doesn't matter which one's B. C is the other one. And then sine 76. It's literally that easy. Now I'm just going to type it in. 26 times 12 is 312 divided by 2. So it's 156 sine 76. So 156 times the sine of 76 is 151.4 millimeters squared. Okay. Oh, and it says to the nearest 100. So I didn't do that quite right. It's 151.366. The 37 would be the answer here. Try the next one. This question will pop up here. See what you get. I made it a little trickier, not a lot, because I threw in the third side. I have the 67 degrees. What are B and C then? Well, they're the two sides that come out of 67 degrees. So these two. So my area is 1/2 9 times 17 times the sine of 67. All right, so 9 times 17 divided by 2 is 76.5 sine of 67. And I get 70.418, so 42. inches squared. Right. So that's it. That's all the area formulas we're going to use for this unit. And that's it for the unit.